Hello, today we are going to talk about the C++ decompiler NSA Ghidra. So what it is, it's this software ghidra-se.org with this GitHub repository NSA Ghidra. Okay, and it says a software reverse engineering SRE suite of tools developed by NSA's Research Directorate. Okay, there's a video tutorial, and you could either install one release, so we have a release from 29 days ago, or I have built this thing from scratch. So in the readme, so github.com/NSA National Security Agency /Ghidra, it says how to build it. So for that, let's go to the directory. So it says get the JDK 17. This is it, JDK 17 for Linux. I'm on Ubuntu 22.04. I've downloaded this thing. I have rgzipped this thing. It's in here. Then it says you need Gradle 7.3 or better. I downloaded the Gradle, which is binary only, and I've put it in here. Okay. Then it says make GCC G++. I have it on Linux. The source code is just this thing called download zip, which I have downloaded in here, Ghidra master. Okay, so I unzipped Ghidra master, this thing. I changed into this directory, and then I need to run gradle -i Gradle support fetch dependencies Gradle. So I don't have Java installed from Ubuntu debs. I don't have Gradle installed from Ubuntu debs. I'm not even sure if I would install them from Ubuntu debs if it's the correct JDK version and the correct Gradle. So that's why I've just downloaded this too. And now I'm running it. I have a script in order to set the correct paths and directories. So I'm going with this thing, which says the Java home to the JDK directory. Otherwise, Gradle refuses to work. And then I have path set to the Gradle bin directory and to the JDK bin directory. And then, so this is prepended to the path environment variable. And then I run what it says. Okay. So the Gradle thing took a while because it does this step, which is download additional build dependencies. So it downloads PyDev, which is an IDE. It downloads Eclipse because this is an Eclipse distribution. Okay, so a ton of downloads. Then it says run Gradle build Ghidra, and I have this command line, which sets again the Java home and the path environment variable. Okay, at the end of the building, I have, it says the compressed development build will be located at build/dist, which is this thing. Okay, I took this file, it's a zip file, contains an entire distribution of Eclipse plus 100 plugins or something. Okay. I put it where? In here. And then I run this command line, so it sets both Java home and path to the correct directories for the JDK that I have just downloaded. So, path is enough for Ghidra. If the bin directory of the JDK is in path, then that's enough for Ghidra. So let's run it. Ctrl-Shift-V. Not like this, but like this. Okay, and at first it shows a so as per the installing Ghidra screen recording. At first it shows some a help, a tips of the day, and an empty project. So you close the help file, the help window. Okay, so I'm closing the tip of the day. I'm closing the previous project. Okay, it says no active project. And the next step is to create a new project. New project, non-shared, so we keep the defaults. The defaults, let's put the today 25. Decompile. The project name. Finish. Okay, so we've created the project. The next thing to do is to add to the project an executable. So for that, let's build using kdesrc. So we have built kdesrc-build kcalc. So we build kcalc using kdesrc-build. And we have configured kdesrc-build to use CMake build configuration debug and directory layout event. So that means that the executables, the binaries, contain debug symbols. So the binaries, the executables, contain dwarf 5 debug symbols, contain the name of the file, where the source code is located, and other debug symbols. Okay, so let's open kdesr. This is the directory where make install will place files, build artifacts. Bin kcalc, this file. We'll drop it over decompile, and it says it's ELF, executable LNK format, correct? It's a binary. It's x86-64, yes, built by GCC. Okay. This is a summary of what Ghidra understood about this executable kcalc. It says it depends on a number of SO files. It has some source code files. This is the path. It has this MD5 and this SHA-256. Okay. there are some caveats, so not everything is understood perfectly by Ghidra. And even now it seems that I didn't set the correct environment for Ghidra to find the correct files. So the SO files. Maybe that's a thing to do. Let me check. Okay, so I'm trying with this concoction. This entire block, I'm pasting it into a terminal. So I set the environment variables path with the tilde/kd/usr/bin, so the location of kcalc, then the jdk bin, and then other environment variables such that Qt and kd applications can find their DLL, their SO files, their plugins, their Qt quick things, styles, etc. And still I get the exact same results, so it says that it can't find libqt5 widgets SO. So my guess it probably Ghidra removes this environment variable or something, or cleans it up. It did find Qt5 GUI though, and Qt5 core. Okay. And now using kcalc, which is the unexecutable, we can do three things. Version tracking, I don't know what this thing does. Debugger, I don't know either. And then code browser, which is the actual decompiler. So we drag kcalc over the Ghidra decompiler. And it says kcalc has not been analyzed yet. Let's do that. It allows me to select what I want to what features of the decompiler I want to use. Okay. Unfortunately, the dwarf extractor does not support the current version of dwarf, which is 5. So I go analyze. Okay, and this is the error message where it says that dwarf 2, 3, or 4 is supported by Ghidra. Dwarf 5 is not supported. And kcalc has dwarf debug symbols in it. It's not a stripped binary, but the version of dwarf symbols is not 2, 3, or 5. It's 2, 3, or 4. It's 5. Okay, let's do a run of what Ghidra decompiler looks like. So this is probably the Eclipse workbench. And then in here we have the sections of the ELF file. So this is the entry where it starts with magic ELF. So this thing, the magic bytes. Okay. It's called eident magic number. Magic string. Okay. For structs, if you hover on the name of the type of the struct, it shows you the layout of that struct. Okay, in the program trees view we have the sections of the ELF file. So this is the entry point inside of the executable file. Then there's BSS with some functions. This is C++ mangling. So C++ symbols which during mangling receive another identifier that is usable when you have the limitations of the C programming language. So the C programming language doesn't have namespaces, doesn't do C# metaprogramming, the templates. Okay, what else? Data, GOT, which is global offset table. External are symbols, so function signatures, which are not defined into kcalc binary, but into an SO file. Dynamic, data rel RO. kcalconst button is from this executable file. Fini array, init array, frame, frame descriptor entry, frame header, exception handler, frame header, frame HDR, exception handler. Qt version, raw data, read-only data. GNU-C XX. Here is the DS. What is a DS? So this is the name of the file from QCore. This is a bit of source code, I'm guessing. FINI text. So this is in fact the entry point. This is the entry point into the executable, the zone where main is defined. Okay, PLT. External GMP, this is a library. GOT. PLT INI. Okay, so there's more sections to come. There's debug ones, debug str, debug lines, have section headers, symbol table, string table, a ton of literal strings. That's shared string table. Segment inter p. This is the interpreter for ELF files. GNU. GNU vendor name. Okay. In the symbol tree, we can evaluate functions. So we can dig until we get to the main function, or we can filter. The main function is which one? So this is the external libc start main from the GNU libc, glibc. These are externals, we don't have decompilation for those, and then we have exports, which we should have decompilation for. Yeah, so the decompiler window was hidden, which is window decompile lore. Okay, so the exported function main was decompiled to a very, in my opinion, readable source code. Totally different from what we can see in the source code. So let's look at that first. File open. Source code, utilities, kcalc, copy, paste, /CMake lists. Okay, let's look at the main function. kcalc cpp at the very end. Okay. So first of all, there's hundreds of QString destructors being called all over the place. So there's int param1 instead of int rgc, char pointer param2 instead of char pointer to array of rgv, which is the same thing. Undefined 4. So here I guess that int was optimized out to undefined 4, which is probably void. Undefined double word, length 4. Okay, so it's a double word. Okay. Then what is local 48? It's a something with lambda. local 48 is used as the second parameter of the constructor of kdlibs for config migrator. This guy is the class name, this is the constructor, this is the object name, so there's no second parameter. Yes, there is a second parameter because constructors have as the first parameter a pointer to this. Okay, now we're in the territory where we can see the sugar syntactics in C++, if it were such a thing to exist. So we can see where this is passed into methods, where this is not passed into methods because the method doesn't exercise this, and there's no point in, there's a micro optimization in there, just not passing this, where the constructor has as the first parameter a pointer to this, where lambdas are defined, where macros are expanded, where QString concatenation, so the plus operator, is converted to QStringBuilder, and all of this desugarizing of C++, and the way methods are called by using a syntax which would look like that method is not a method, but it's a static method. So there's very little difference between the way a static is called versus the way a static method is called versus a method is called. It's the same thing. It's the definition of the, and even operators, how they desugarize operators, like operators, operator parentheses, and operator less than, and even operators with really strange and huge names. Yes, how do they cast in places where we wouldn't expect such a cast to exist? A ton of destructors for strings when they go out of scope for QString. So I totally did not expect these many method calls in such a small method. So it's less than 100 lines of code, and that expands to a ton of constructors, constructor calls, destructor calls, totally did not see this coming. So yeah, I know that objects allocated on the stack, so local variables that you define without new, are getting destroyed when they exit the scope. Then this richness, this huge number of destructors, that's quite a surprise for me. Okay, let's look at the destructor for Q command line parser, for instance. Where is that thing? So this Q command line parser, local 58, is defined in here. So it says Q command line parser all of the local variable names are lost, because that's the way it is. So all of the locals are named local underscore something. And then it says it's calling Q command line parser constructor with one parameter, which is local 58, which is parser in the source code. And this local 58 where are you? Is a QString. Why would it be a QString? I would expect this to be a Q command line parser. So local 58. And then Q command line process. Parser.process of app. It casts local 58, which is a string, a QString to Q command line parser pointer. And then when it says process, parser.process, it casts local 58 to Q core application pointer. Q core local 58 as QString was just destroyed on line 191. Okay, about data, process command line of parser. So local 58 is now a Q command line parser. Q command line parser dot process is a Q core application. Setup command line receives the parser as a parameter. No, it receives local 88, which is a Q command line parser. Local 88. Which local 88 is a K about data. I know. The names of local variables don't seem to make sense. Yeah, but still it makes visible the call of methods. The call of constructor, you can see for each method and constructor, you can see the type that it's defined on. So setup command line is on K about data. This thing. You see it that it's a member of setup command line. It's a member of K about data. And receives a pointer to parser, command line parser. So it's, for me, it's easier like this in the decompiled version to read these pairs of type method, or destructor, or constructor. Okay. So there's a destroyer for kabout data after the application goes up.exec. So before the end curly bracket, there's destructors for Q command line, local 58, which is the parser, and kabout data, which is local 88, which is about data, and kdlibs for config migrator. So none of these were declared with new, which is good. We should use rarely new in C++ code. Okay. Then it goes application destroyer of application local 38, where qapplication.exec and uvar2 is autocalc. Return uvar2 up exec. Okay, so it declares a local variable for up.exec in order to be able to return it, because you can return only on the last line before the closing curly bracket. So all of the destroyers get called before return uvar2, which is the local variable, which is the value of this. kcalculator operator new. So this thing, it says operator.new. So operator.new in this case is split as two decompiled lines. One which is operator.new, which just allocates memory. So in hexadecimal for 80 bytes. So 0x for 80 bytes. And then that void pointer is casted to kcalculator pointer, and then that it's stored in local 40, which is autocalc, the calc variable. And then that local 40 is used to call the constructor kcalculator kcalculator local 40 so this is the this pointer, and then there's a null pointer which is 0, and that thing is cast to qwidget, which is probably the parent. Or something, let's see. So the kcalculator, yeah, qwidget parent to make this model. Probably, I'm guessing. So really interesting how the constructor is called for when you use new, so it's this thing, and when you do not use new, which is this thing. So the same constructor is called with the same first parameter, which is this, but then this might be allocated first with a operator.new. If you use the syntax in C++, new, then the type name versus the type name, and then parentheses. Okay, so it makes sense why you need to manually deallocate the memory which is allocated by new. Okay. So local 40, this thing is probably stored inside of a calculator, and then where are you? That is deallocated somewhere later down the line by the Qt frameworks widget parent deallocation functionality. Okay. What does this thing do? Stack check fail local 20 not long in fs offset plus. So I have seen a ton of id plus address. Where do we have those? Let's see. A type from this module. What would that be? This thing set decimal separator. Let's search for this. So both these symbol tree labels and then the mangled C++ take us to the same place, and the class is knumber set decimal separator method. Okay, so since we have all of the assembly from kcalc, the binary, we have the assembly from set decimal separator. This is not an external. So the source code looks like decimal separator equals ch. So even when we don't put returns, this is just sugar syntactics for putting returns with no parameter. And then was it in here evident that operator equals is called? No way. Okay, so why is operator equals called of QString? Because the parameter of the method is const QString reference, which gets desugarized to QString pointer, and then that thing is std call, because it doesn't have this, otherwise it would be this call or something. Let's look back. So it's std call, which is strange for me. Why would it be std call when it should be probably cdecl? Okay. Decimal separator and ch. And where can we see that it's a static, not a member? Set decimal. Yeah, it says static void. Okay. So no need for this. So it receives a ch and it says set decimal separator, where decimal separator is a data member. which is in fact a what? A private static QString. And it has a value, a default value. Okay, so it sets into the static member, the member of the class, not of the object, this ch, which is operator equal. So it takes decimal separator, which is defined as QString. Okay, it is a reference, it dereferences it, and then it casts it to QString pointer, and then that thing is a is an object, and then that object has a method which is the operator equals. So it does kind of like decimal separator dot equals or dot operator equals, and then parenthesis param1. Which is interesting, an interesting way of looking at things. So a copy constructor, right? An equals operator. Very interesting. Okay, let's look at a method that's not static. Which is this thing, pow. There's tons of pow. A pow of key number. Key number error, key number float, key number fraction, key number integer, and just plain key number. Okay. Show me this. Does this have an implementation? Yes, it has. So it says it returns a key number. No, it returns a pointer to a key number. And then key number, wow, the method. Now doesn't have one parameter, it has two. The param1 is this. And const key number reference is desugarize to key number pointer. And then param2. And then there's two local variables in here, which I don't know which they are. So lvar1 in fs offset. I have seen this thing in fs offset a ton. So key number pow is what? This thing. But then this thing doesn't, I have seen it in many functions. I'm not sure it does anything. Simplify. Okay, let's find something easier. Key number, that's too complicated. kcalc CPP. resize event. So it's protected kcalculator resize event. Let's see what this thing does. There's more than one. So maybe something inherited from KXML GUI window or from private UI kcalculator. Ctrl+Shift+F, search. Yeah, there's a KXML GUI window resize event. Okay. Because in here I can see there's one which receives a parameter, where force, no, that's another thing. So kcalculator resize, this thing. Okay, so kcalculator resize event. Why doesn't this thing receive a this? I don't know. Protected override qResize event. So I don't see any this is in here. What about update geometry? Stay down, stay put. Okay, kcalculator this. So this guy is this call. From what I see, if it receives this, it's a calling convention this call, otherwise it's calling convention std call. Okay, let's look at update geometry. A huge method. So 1 million of local variables. Lambdas. Operator not equals of QList of QObject pointer of const iterator. So this is the for each syntax in C++, and we can see the begin and end of the containers. So how many loops are there in here? So 3 for eaches in the source code. In the decompiled, there's 3 while trues. Pretty interesting, right? Okay, let's look at the first for each while true. So it says left pad children, that's QObject children, and then it does this plus offset 1008, so decimal 264. This is a kcalculator pointer, and plus 264 is, I don't know What? A data member, I'm guessing. I'm not sure how I can get to that. So children. Let's look at the source code. So this, where is this? Left pad is a member of this. kcalc. UI kcalculator. And kcalculator implements UI kcalculator. So that's where left pad is. So left pad is in fact this dot left pad with a pointer. Yeah, it does auto-completion. Okay. So it takes this and it does pointer arithmetics with +264, and that thing is this, the member, the field left pad of this. So this is at 264. Okay, so this thing is this thing, and then it takes that thing and it converts it to, who knows what this is, a pointer to a QObject list. Why would it do that? And then everything is a pointer. Because left pad is what? Is QWidget, but children is a member of QObject, which is this thing. Control W. Okay, so once it gets to left pad, then it calls the method QObject children. This is sent there as the parameter this. So the result of the pointer arithmetics, which is in fact left pad. Okay, and this returns a inline const QObject list reference const, which everything is then desugarized to QList pointer. So it's a pointer to QList. Okay, and then that thing is stored into left pad list, which is pqvar5, which is a QList pointer. And then that thing is used as the container for the for each. And let's see what it does. So it took pqvar5 just as a pointer. So now it will call the QList constructor to convert the raw pointer pqvar5 into local 98, which is in fact a QList of QObject pointer, which is local 98 is in fact left pad list. Okay, local 98, local 70, and then it calls begin and end on what? On nothing. So without parameters, QList of QObject begin, QList of QObject pointer end, with no parameters. Why would it do such a thing? I don't know. Okay, and then it takes a const iterator operator not equals const iterator local 80, which is the this of the not equals operator, and then local 78, which again we don't know what it is what, 3? Used to be 3. If cvar1 equals the null string and cvar what is it? Then it breaks. But then that's the condition in the iterator. I know. So hours and hours of fun in here, desugarizing C++. And that's just things which are easy to desugarize, which are constructors and new operator, and where does this method come from the inheritance chain, and casting, and for each C++ for eaches, and how do we hide iterators and containers, and it's not even getting near of the lambdas. But at least we can look at what the various C++ macros used by Qt expand to. So let's find such a thing. Okay, let's look at qDebug. String to category. So it says classes anonymous namespace. Yeah, it's in the anonymous namespace. And then there's this thing is a free function. So returns undefined 8, which is what? A quad word. Which constant category is an enum. Okay, so string to category takes a const qchar reference, which is a pointer to qstring. Okay, many local variables that we don't expect. If s return, if s return, if s return, if s return, these are returned early. They don't seem to exist in the decompile thing. Seem to be replaced with an arrow, which is a if with a ton of indentation. Okay, where is the interesting thing? So this doesn't mean much. Where is qDebug invalid category for constant? It's probably this guy. Okay, so a verbatim a string literal. So the string literal remained a string literal, invalid category for constant. It would be fun to search it in the sections of the ELF file. Okay. So qDebug, what does it expand to? It's a define. Okay, so should have been all uppercase because it's a define, right? And then it says qMessageLogger, which is true. There's a qMessageLogger in here. And then it says qMessageLog file, which is __ file cast to const char pointer. So this is for UTF-8. And then line, which is an integer. And then func, which is a UTF version of the function name. Let's go back. So the function name is in all of its C++ glory, demangled, qfunction for this thing, which is in fact pretty function. Okay, we have a help for pretty function. No, we don't. Okay, but we understand what that means. So there's two strings and an integer. So log line is 43. File. So file is there is a symbol s underscore and then the start of the string and then underscore and the hexadecimal. Okay. What is this thing? Another symbol. S constant category anonymous SD. Okay, has an address. What is this thing? A symbol. Where do we see these symbols? In here. So S underscore. How can we navigate to this thing? So it's in I don't know which section, but it's in a section. The literal string has a symbol, has a value, is used. Okay. So that's to expect the fact that at compile time the macros are expanded to the values that exist during compilation. That's totally to be expected. And then it says, where are you, qDebug? It's a constructor not with new, which is true. 3 parameters plus this. So local 38 is the this qMessageLogger pointer. Okay. And then on it, it calls the debug method. And then no parentheses because the parentheses are from the source code. Interesting, interesting. Okay, let's look at the qMessageLogger constructor. So it's empty. What's context? Context is a qmessage log context. It just initializes context. Okay. So it's in fact the other constructor, the one without categories, so the category will be default. Okay, so this is the call to the constructor, and then it calls qMessageLogger debug without any this. How could it do such a thing? So it could decompile qMessageLogger constructor because qMessageLogger constructor is defined not in the CPP file, in the Qt library and framework, but in a H file. So the entire constructor with its implementation exists inside of the H file, so it will be part of the calling file, which is kcalc const menu cpp. Okay, so it says void this call because it's a constructor and receives this as the first parameter. Can we have tabs in here? Yes. Great. Okay. So qMessageLogger this param1, param2, param3. So there's 1, 2, 3 parameters plus this, and this in fact calls the context with default. So qMessageLog context and the default verbatim string, string literal, and this thing is qMessageLogger context. So this, which is this cast to qMessageLog context pointer. Why? Why would it do such a thing? This context, why doesn't it have its own this? Why should we pass the this from qMessageLogger to qMessageLog context? This is the constructor. File name, line number, function name, category name. again declared in the H, not in the CPP file, including its implementation. This thing is surprising. Why would it say this in here? Because it makes you think it's this. Okay. And then what does the operator less than do? So it's an operator on qDebug. So it says local 40, which we don't see. qDebug. The management of local variables seems off. So qDebug is local 40, right? And then qDebug is not initialized anywhere. Control F. It's just used in the operator less than. It's not used in qMessageLogger colon debug, even though this probably is the result of qMessageLogger debug. qMessageLogger debug method. Let's get there. Debug this thing. So print file or print as printf style or printf style is just a message and then a vararg. And then this is for safety features in the compilers. So we don't have the source code of debug, which is strange. So debug in fact returns no void. But it's still a member. It certainly does something on this. So after it prints this thing, it stores this thing in qMessageLogger. So what's local 40? qDebug operator less than with a const char pointer stream arrow ts qtext stream pointer qstring from utf-8 of t and then maybe space. Yeah, interesting. And then qDebug is distracted because destroyed. And it does operator less than one more time. On this and on param1. Which is this S. And this is what? qDebug pointer. So operator less than returns a this, and then that is used as the this first parameter to the operator less than. Boof. Okay, return mathematics uvar2, which is this thing, which is in fact 1. Why is mathematics 1? Because mathematics is 1. So return mathematics in fact is a return 1. Okay, and the return type is undefined 8. Okay, so we have seen offsets, so it goes this plus something. We have seen how C macros expand. In here we have seen operators, operator less than. Plenty of interesting things in here to see. Plenty. kcalc CPP, let's go one more time in here. Don't we find a simpler method? Status bar, let's look at this thing. Where are you? kcalculator status bar, this thing. So again, the executables are built with CMake build configuration debug. So I'm not sure if that's the same as -OG. I'm not sure how many optimizations are allowed for the GCC compiler to actually perform in this scenario. So it says Q main window status bar. And then return. So this thing looks like kcalculator status bar. What about this? So maybe the decompiler is not good enough, because I don't see how we can make this conversion, such a conversion from this source code to this decompiled version. Because it just calls qmain window status bar, and then it ignores its return, and then it returns nothing, and then the type is void instead of kcalc status bar. Oh, that's another thing. So kcalc status bar. kcalculator status bar. No, it was that thing. Okay, let's look at create constants menu. Yeah, maybe the decompilation is not perfect, in the sense that maybe this is true, but maybe this is not true. Unable to resolve type connection. Okay, can't decompile that. Let's look at slot heap toggled. Control V. So there's a symbol, label, and then a method, which are the same thing. Okay, kcalculator slot heap toggled of bool. Okay, so bool is the flag, param1. Okay, in here it doesn't do syntax, it doesn't do pointer arithmetics with a plus, it does pointer arithmetics with a square parenthesis. It's the same thing as doing this plus that thing. Okay, so the parameter, which is flag a bool, param1, is cast to kcalculator. Why would it do such a thing? And then heap mode, which is a bool, and it's cast to kcalculator without any pointers. Oh. I know. So it's a bool and it's attributed to a bool field, which is this thing. So equality, or whatever. Not equality, but assignment operator equals. So this, which is a kcalculator pointer, has a member, which is this 841 in decimal, 349 in hexadecimal, which is heap mode, which is a private bool member of kcalculator. Right, so it's the same thing as this will be here. Heap mode underscore, so it's a private field. Okay, and then it says qemit, whatever that thing is. Nothing. Doesn't seem to be anything. Maybe both the decompiler and me, we're wrong. And then it says switch mode, which switch mode is again a member of this, a method. So this thing, switch mode, is called with this as the first parameter, then mode hyperbolic, which is 2, and then flag, which is the bool parameter. Yeah, and this call because it has this as parameter. What is this thing? An empty parenthesis. So kcalculator slot memory call clicked. Aye. So there's 3 labels. One with underscore z, one with underscore zz, and one with underscore zzz. One, two, and this, I don't know, can't be 3 z's. What's the difference between these two? Okay, and the other thing is actually the method. So there's the method, which is this thing, slot mem recall clicked, this call, pointer of kcalculator, this, returns void. Yep. So the first thing is bulk display being somehow a member of this, I'm guessing. Yeah, it's of UI kcalculator, which is a parent class that kcalculator inherits from. Then send event, so kcalc display, send event, and then pointer arithmetic this plus hexadecimal 58, and then that's this minus greater than calc display, send event with this thing which is probably 0, and it needs to call to send this thing twice because temporary workaround, okay. And then it says add to history, which it needs to prepare a lambda for. Add to history, this thing. How many lambdas exist in here? So I can see this guy. Are there any lambdas? No, that's the only one. Okay, it's local underscore 28. This is where it's defined. This is where it gets something. I know what. And then it's used at qFlags constructor or something. Let's look. So where is this thing? Slot memory call clicked. It's this thing, update display. Update display. Update display qFlags of this. Where update display is what? What is update display? Is a member method. So why does it call it like this, not kcalculator : something? What parameters does it have? Update flags, which is a flags, which is what? qFlags enum, which is a parameter of that thing, and enum is what? Update flag. So from update flag, which is an enum, it creates a flag in the C# sense. Okay, I understand that thing. So it's an empty bit set, or an empty flag. No enum in there. Okay, but then why is the lambda needed? In kcalc, add to history. What is QStringLiteral? Oh, mama, QStringLiteral is a lambda. Yes. So QStringLiteral is implemented with a C define, and then inside there's a lambda, a C++ lambda. When the C++ standards allow. When the C++ standard allows, I'm guessing. Okay, so it's, what's that? No return type, no input parameters, and then returns a string, or what is this? And then a body, and then the body does capture of str, which is a what? Which is the verbatim string. mr, where is the mr? Where is mr? So this is the way you finally can decide which of the Qt string types is best for what. So the choice is between QStringLiteral, QLatin1 string, QString of nothing, QString of empty string, QStringLiteral of empty string, QStringLiteral of QString, QStringLiteral of string literal, etc. So for nothing, for the empty literal string, for literal strings, and then for conversions from one another. And then there's the optimization with QString plus operator that uses a QStringBuilder. I don't know, as a C macro or as a C++ lambda. So this is the way to actually look. You create a minimal project where you do all of these things in source code, and then you desugarize them using the NSA Ghidra, and then you actually see what's happening in there. Okay, so for all QStringLiteral instances, there's all of this machinery behind. So it has a lambda, which needs to be, in this case, is defined in here. Lambda number 1. This call receives a this. Oh, QString data pointer. QString constructor of this, and then qvar2, which is a what? A qstatic string data of 2 data pointer, QStringLiteral operator, parentheses, parentheses. Yeah, great stuff. Okay, let's look at a string concatenation, and then that should be it. If we can find it, if you can find one really easy. What is this? This could be it. So set up static keys. Doesn't work, unfortunately. What about this thing? Slot log clicked. Okay. So although your eyes can see a QStringLiteral, which probably gets translated to QString, maybe so, maybe no. Another one, and then whatever this thing is, but then this calls to QString, so this probably is a QString, right? So QString. So you would think that there's some plus operator on the QString Qt class. In fact, what you will see is this thing, the QStringBuilder. Once, twice. Okay. Operator plus on we do not know what. With local 48 as a QStringBuilder pointer, which is a QString. And then operator cast to QString of local 50. Okay, so that was it. So I'm glad that we can decompile really well C++ binary code. So binary is compiled from C++ code with the caveats that I have, in the sense that I build them with CMake build configuration debug. I have all of the dependencies built like this, so all of the Qt libraries and all of the KDE framework libraries. And then the decompilation of one method is really readable for me. Yeah, we lack the names of the local variables, but then everything is super readable. And I'm glad that the output of the decompiler is so high quality. And I'm glad that I can see with the conversion from C++ code, GCC, compiler, binary, and then decompiler using NSA Ghidra, that I can see another view on the C++ code, on the original C++ source code. I can see it using a different mirror and from a different perspective. So the original source code lacks a ton of context. You need to navigate a ton in each identifier in here to see what's really happening behind the scene, whereas the decompile code, it contains way much more it's much more redundant. It shows the true class name, the true method name. It would be super tedious for the human to write all of the class names and all of the methods each and every time you do a simple object.member source code. Whenever you write object.member, you want to see the minimum characters of things in your source code. You don't want to go with QStringBuilder : operator .cast.to QString parentheses of something, you know. But still, it's useful for me to see what the decompiler does. Because this way I can see what the designers of the Qt framework thought and what they did and why they did what they did. I can see through the C macros, I can see through the C++ lambdas, etc. So NSA Ghidra is really good. Thank you for existing, and thank you.